So while computer vision models become more and more precise, accurate, and evolved, they're also becoming more resource hungry and expensive for 24/7 video analytics on the edge devices. If you're curious about how Microsoft Rocket and live video analytics put together will improve your video analytics by sometimes 17 factor and eventually go from 10 frame per second analytics to something up to 200 of them, if not 700, with some little loss in quality. So today we have Ganesh and Avi from Microsoft Rocket and live video analytics, who are here on the IoT show to tell us exactly how that works. Hi, everyone. You're watching the Internet of Things show. I'm Olivier, your host, and today we have Avi and Ganesh with us to talk about vision AI at the edge and how to make all of that work in today's world. Hey, guys. Thanks for joining us today on the show.
Hey, Olivier.
Hey,
So,
Olivier.
Ganesh, how about you introduce yourself first for our audience? Who are you? What are you doing at Microsoft?
Sure. I'm Ganesh. I'm a principal researcher at Microsoft Research. I've been here for over 6 years now, which I joined after my PhD in Berkeley. My research has spanned, large-scale cloud systems, big data analytics, and wide area networking. And of late, I've focused on video analytics, which is what I'm excited to talk about more in the show today.
Awesome. Avi, how about you? Who are you and what is your role in the company?
Yeah, so my name is Avi Kevalramani. I'm a product manager here in Azure, specifically in the Azure Media Services team. And my focus right now is basically live video analytics on the IoT Edge, which is a platform product that we just shipped last month, actually. So I'm focused on different video analytics use cases on the edge.
Awesome. So we had Milan actually on the show recently talking about or introducing live video analytics on IT Edge. It was a pretty interesting episode that we invite people to go see. But we'll talk a bit more about the AI part. So let's actually discuss first what are the various use cases that we expect to have LVA being useful, and then we'll look closer at the project that Ganesh is working on with this team and how it fits with the LVA story.
Yeah, so Olivier, I think live video analytics or video analytics in general is a very broad range of capability, or at least the capability has a broad range of applications. As you see here, it's applicable across almost every industry today. It's applicable in retail across different use cases, primarily one of them being shelf stockout, which is like a 1 trillion business problem. In transportation for something like an aircraft turnaround. Healthcare, specifically patient monitoring and ensuring that diseases are caught early. In public safety, which is important nowadays because we are in a situation of a pandemic, to ensure that pedestrians are safe. There's commercial security, there's distancing between people where relevant, critical infrastructure protection, as well as manufacturing. So there's a broad range of use cases and industries that video analytics is applicable to. What I also want to do is, just run a couple of videos we have here, and they will showcase for you what we've been doing with it. So what you're seeing on the left here on the top is basically a parking analysis application that we built. And on the bottom left, what you're seeing is basically a vehicle counting application on top of the live video analytics and Rocket platform. And you see how when a car came in, the road store, actually the count went from 5 to 6. So you can do a lot of such analytics from video feeds across different use cases in different industry verticals.
I see. Yeah, indeed. Definitely lots of scenarios, especially in the IoT space that can use LVA. So, but let's look a bit closer at what really that means to run that AI at the edge, and how you bring that intelligence that is trained in the cloud to do this kind of counting and others on the IoT edge devices themselves. Let's have a closer look at that.
Sure. So let me quickly go into talking about the LVA IoT Edge platform. Like you said, you had the show with Milan, so I won't dive deep into it, but I want to highlight like 3 aspects of this, right? One is the point that you asked about, how do you bring AI into the live video analytics platform? It's via AI extensibility. So how you do via AI extensibility is the platform itself has the capability to interface with an external module via a simple REST-based endpoint or a gRPC-based endpoint for high frame rate or low frame rate scenarios of video analytics. The second aspect, which is important here, when I want to call out, is we work with any cameras, right? So we don't require special camera installations. When I say we, I mean live video analytics. And then the third important point is it's all on the customer's edge. So the edge box that you see here, it's all on your own edge. So those are the aspects which sort of light up these various scenarios of video analytics at scale on the edge.
Cool, Avi. So it feels to me that we are not overloading, but putting more and more on the shoulder of that poor edge device there. So what are we doing to allow our customers to run that much intelligence at the edge on these devices? What are our recommendations in that space?
Sure. So that's a great question, Olivia. Let me show you this. So number one, like I said, we work on different kind of edge devices, but one of the key first-party Microsoft device, edge device that we work with is Azure Stack Edge. This is a server-grade edge gateway that brings hardware acceleration to the edge, and the LVA plus Rocket integrated pipeline works seamlessly across this device. The second aspect is, the question you asked is what kind of other recommendations or work we've done in the area to make sure that compute is efficient on the edge. I want to highlight this portion here. This is where our work with Rocket comes in. So what is important to know here is what we are releasing or talking about today is a reference app, and this is a reference app in open source. And in this reference app, the live video analytics pipeline, which is the blue box here, basically plays the role of ingesting the video feed, decoding the video feed, passing the video feed onto external container like the Rocket container, and collecting JSON-based analytic signals and relaying those to the edge and the cloud. The critical role that Microsoft Rocket plays here is they bring the cutting edge research and the infrastructure to build sort of a cascaded pipeline of operators here on the edge, which lets users bring their AI model. That AI model could be a first party Microsoft model or their own model, and plug it into the Rocket container and really have a very efficient pipeline right there on the edge. So that's what we're going to talk about today. I think the other couple of key points which I want to mention is, the way we are integrated is pretty seamless. We are not changing any of the developer experience. And so that sort of relates to our developer ecosystem because how they work with LVA today remains the same when they're working with LVA and Rocket together. And the other portion is we are not sort of doing it for one specific AI model. In the example, we'll show you a vehicle analytics model. But like I said, in the spirit of democratizing custom vision and analytics on the edge, you can bring any model you want from any industry use case and plug into this pipeline, and you would derive the benefits of high throughput processing on the edge with this reference application.
Along that. So I'll see if, and correct me if I see it wrong, live video analytics becomes the easy way to ingest, data from different types of camera, make it super easy to kind of route and build, the initial pipeline, and then you hook up your own intelligence, your own models, and Microsoft Rocket is helping there. What else is Microsoft Rocket really focusing on in terms of problems, and what is it solving for our customers beyond just bringing their own AI models?
Yeah, that's a great question, Olivier. So here is basically how we think about the customer problem, right? We talk to customers. Let's talk about the drivers of live video analytics, specifically live video analytics on the edge, right? There's three major drivers that are driving live video analytics today. One is advances in computer vision and machine learning, right? It's like the golden era of computer vision today. Second is there's a broad deployment of cameras. Some statistics claim there's about 6 billion CCTV cameras in the world. And third is actually industries and customers within those industries are open to leveraging video analytics for positive business outcomes. So these are the drivers for live video analytics. Coupled with that, if you think about video is very heavy and you need real-time insights. So latency is important. And also bandwidth is not very huge on the, you can't send all the video to the cloud. So it's an edge first problem. Because of the latency, because of the bandwidth, you have to have a lot of computational footprint on the edge. This sort of drives the total cost of ownership, because customers think about how many frames per second from a video stream and how many such video streams can we process on one edge core. Like an example I'm giving you here, just to do a long traffic video analysis across a dense, let's say a traffic intersection, takes about $200 per month per camera stream. Imagine scaling it to like tens of hundreds of cameras, and the total cost of ownership just blows up. So that's the core of the problem that we are trying to solve for with the LVA and Rocket coming together. And this is the IP, or this is the cutting edge research that Rocket brings forth, which you will see how it solves for this problem.
Awesome. I think in addition to the bandwidth problem, people should not forget to think about the privacy issues for not being able to send all the data to the cloud systematically, especially when you're actually filming or working on videos of people or things that can eventually go against the privacy rules that we want to abide by. So let's look into Microsoft Rocket. Ganesh, maybe you can actually give us some insights of how Microsoft Rocket works to reduce that TCO for our customers.
Sure. Yeah. So Rocket is a project that we've been pursuing now for about 4 years or so, and we came at it from the excitement of what we saw with the amount of cameras being deployed, the advancements in machine learning models in computer vision, especially, and we came at it from the angle that we really wanted to make this low cost, such that anybody who had a camera stream could just run these video analytics 24/7, get intelligence and get actionable outputs out of it. So our objective was to build a video analytics system that was low cost, yet accurate, and at the same time also respect the privacy that's inherent in video data. Thus, we believe truly democratizing live video analytics. Right from the beginning, we've been seeing video analytics and edge computing as very much together as a story. In fact, the article down there, where there is a link, there was something that we wrote about 3 years ago, where we were forecasting that live video analytics essentially will be the killer app for edge computing. And yeah, now we're starting to see more and more of video analytics and edge together. And so yeah, that's a good thing.
Awesome. And well, let's discuss a bit how that works, right? Because I'm hearing you telling that it democratizes vision, analytics, video analytics, which is not something that in my mind or my first reaction I would consider as easy and simple, right? It implies things around training machine learning models and bringing in video feeds. And how are you guys making that simpler, and how do you build up that pipeline that you alluded to a second ago?
Yes, so along the way in this project, we have developed a whole suite of technologies that optimize the cost of video processing. And we've tested these technologies in a whole bunch of customer engagements and pilots in real-world scenarios. And in fact, one such technique that we are actually going to talk about in detail today is about cascaded video pipelines. Right. So one such technology that we're releasing is the cascaded video analytics pipeline. The boxes in the middle show the various components that are used in processing every single video frame. As the frame comes in, we run it through a simple motion background subtraction detector. I say simple because this is stuff that can just run on generic CPUs. And then after that, we focus the whole attention onto a certain line of interest or a region of interest in the frame, such that if there is any movement at other parts of the frame, we don't really care. We don't have to invoke anything else. And like for the example below, you see that a car has just crossed that line of interest marked in red on the frame. Then we run it through a light DNN or a light neural network. The light neural network, the good thing is that it's substantially cheaper, but at the same time, its confidence sometimes can be wobbly. So if this confidence is not good enough, then we go into asking the heavy DNN saying, hey, can you really confirm this was a car? As you can see from this cascaded mode of execution, if there is nothing happening in the region of interest, or if the light DNN itself does the job, we don't even have to go to the heavy DNN detector. And this is, in a nutshell, the reason why the live video analytics with a cascaded pipeline is substantially more efficient, because we're very sparing in how often we go to the GPU for these heavy DNN operations.
I like that. You're basically adding a level of intelligence to not work. It's the lazy model, basically, right? Don't do the work if you don't need to.
Yes, exactly. If there's no need to work, let's not work. Let's take rest.
I like that. That's totally me. Awesome. So, Avi, maybe you can tell us how Project Rocket actually works. How do you integrate, the cascaded video analytics pipeline with live video analytics?
Absolutely. So what I want to showcase today here is basically, I think Ganesh just talked about the cascaded pipeline, and that's here, the orange portion, which is the Microsoft Rocket container. We just talked about the cascaded pipeline. This container is basically talking to the live video analytics platform, which is the green box here on the left, and is interfacing over REST. So the video comes into LVA, becomes frames. These frames are sent over REST interface into Microsoft Rocket container. The container does its magic, sends the results of the analytics on every frame back as a JSON response saying, hey, I saw a car or I saw a person. In this case, we are looking for cars. And once it comes back to LVA, LVA does the relay of these signals to IoT Hub. This IoT Hub is in the cloud. So what happens is you now have signals which have been generated on the edge but have reached the cloud. The other thing which LVA does is it also, creates AMS assets, but you can think of these as video files on the cloud which are playable. So let's say you find a car or you find a couple of cars and you say, okay, between last half an hour window, I saw 500 cars and that's an anomaly. You can actually take video clips and send them to the cloud for playback. So you will see here, these kind of clips, video clips get generated on the cloud and they can be integrated with any app to be played back easily so that the person who's actually understanding the analytics can look at things and go take a response. Additionally, since the signals are on the IoT Hub, you can now bring the power of Azure. You can bring Azure time series insights or other such capabilities on the cloud and interact with the IoT Hub to produce analytics. And I'll talk about this analytics in detail, but what you see here is a chart which shows you how the traffic is growing over a 36-year period, or 36-hour period, actually.
Yeah.
So that's
Yeah,
the
it would have been a
power
long
of the
time.
integration.
I don't think that building was here 36 years ago, but
Yeah.
cool. So, Avi, you've been teasing us now. We need to see a demo on how that works, right?
Mm-hmm. Sure.
Let's jump into a short demo.
Sure. So let me do that actually, Olivier. And what I'm going to show you today is basically, let me start with here. So I've been talking about what we are shipping, and I want to showcase that first. We are shipping a whole notebook experience, which basically lets the developer bring this pipeline on their edge device and run it, right? So we have a whole edge notebook that we are shipping here. We've talked about this architecture. There are a few things. There are certain prerequisite items that we've given you out of the box. You just have to run these notebooks and you'll be ready to go. The important aspects are these points here, like how do you run LVA and Rocket on IoT Edge device together? There are 4 notebooks. For the first one of them, basically gives you instructions to build your own customized Rocket Docker image if you need to. You don't have to do that. We are also shipping a container, a Rocket container into Microsoft Container Registry, and you can just download it from there. It's pre-linked into the notebook, so you should be good to go there. The second section here is basically, how do you configure the lines of interest? Like, it's one thing to say, I want to count cars, but another thing to say, I want to count cars when they cross this specific line in the video. So there's a section we'll talk through that will explain you that part. And then the final section is, what exactly is this combined pipeline and how do you run it? So let me walk you those 4 sections together, and we'll come to the final section of discussing what the output looks like. And I'll switch between a few frames here, or few tabs here. So I apologize for that, but let me walk you guys through that. So like I said, the first notebook is basically a step-by-step of how you can build this container image, the Rocket image on Linux or Windows. Again, it's pretty straightforward. We've taken away all the trouble of how to do this. Just follow it along and you should be good to go. The second is a notebook is basically how would you configure a line of interest. So what is a line of interest? A line of interest is basically a line within one of the frames or images from a video that is drawn, and you can draw it with any kind of player like a VLC player, and it gives you coordinates, the pixels coordinates. And these are the coordinates that you take in and you put it into a file. And this file is provided as input into the Rocket container so that it knows in the video that I'm looking at, there is a line which is visually drawn at a specific point, and if any object crosses that line of interest, then the AI should take some action. That's the whole idea of generating lines of interest within the video. And again, we've given you step-by-step instructions of how to do it. You can play around with it and give us feedback. The third aspect is once you have this line of interest, then what do? You come to the next notebook, and I want to highlight this thing here. I think Ganesh talked about the whole cascaded pipeline, but there are many configurations within the cascaded pipeline. As an example, let me just click on this, and you will see there's like this is the first configuration, this is the second configuration. Depending on what you want to do in your use case, you can pick one of these configurations, and it's very simple to pick. You can just use it like a flag on the command line, and one of these configurations within the Rocket cascaded pipeline will run. Of course, we've given you instructions here to do that. Once it runs, then what is also important is to think about what kind of sampling factor and resolution factor do you need. And these are two important sort of configurations because they sort of drive to the meat of the problem that we are trying to solve for, right? The throughput or the number of frames processed per second on the edge device or the edge core is directly related to what kind of sampling factor you use to sample the frames from the video and what kind of resolutions of frame you're passing to the most heaviest and through that cascaded pipeline sort of. So these are important configurations to know of. We provided you instructions to understand and set those. Once you have this going, then what you will do is you will deploy the LVA and Rocket modules together. And if everything goes to plan, you will have a bunch of IoT Edge modules running on the edge. And at this point, let me just switch to the command line and show you, actually, that's what we have done. So what I've run here is a command sudo IoT Edge list, which shows you a few things, right? You can see here, of course, the Azure IoT Edge runtime and the hub agent are running. There is the live video analytics IoT Edge module running standalone. And then that module is talking to the Rocket count full cascade. We took a configuration of full cascade and we deployed it as a container here. And these two containers basically are talking to each other. And then just for the sake of demo, we have taken an RTSP simulator instead of a live camera. This module here, RTSP simulator, feeds the video into live video analytics. Live video analytics talks to Rocket, and thereby the whole pipeline that we showed you comes to life on the edge.
And actually, an interesting side effect, or actually not even side effect, but using IoT Edge, then that means that you can reconfigure or change which of these modules are running, on the flight. That you don't need to reflash the firmware of that device or whatnot. From the comfort of the cloud, you can decide what's running on that IoT Edge device, and so which configuration of Microsoft Rocket and LVA are running on these devices.
That's great. That's the beauty of IoT Edge runtime and the whole IoT Edge ecosystem, and that's why our dependency, that's why LVA has been launched on IoT Edge runtime, because it provides that capability which you just talked about, right? It's ease of use for the developer.
Awesome.
Right. So once we do this, right, once we run this pipeline, the next set of steps is, or once we deploy those modules, then you'd be like, okay, how do things run? I won't go into a detail of everything, but we have a concept of a graph. You run a graph within the live video analytics pipeline, and this graph basically relays things to the Rocket pipeline. This is the graph topology which you see here. I'm just flashing it through. Once you deploy the topology and create the instance of the graph and run the topology, what you would get on the other side is basically signals. And let me switch to the fourth notebook here. You would get two things. One, you will get frames which are marked, and I can show you that as well. Like if you look here, here's the output folder, right? And in the output folder, you see a frame, which is the number of the frame, the exact module within the cascaded pipeline that ran, and what kind of line of interest that frame was generated for. For example, here you have left entrance and right entrance, so there could be two line of interest crossed or one of those. And then the second thing that you get is also this output, this inferences, which I'll show you again pretty soon in a time series insights way of how you could use it. These get relayed through that IoT Edge runtime from the edge to the cloud into a IoT hub. And these could be analyzed as a stream. And all of this is basically automatically done for you if you run this pipeline on the edge.
Love it. And by the way, I want to reiterate that in that data that is sent to the cloud, there's nothing that is about the person is being captured. There's no photo in there. There's no video. It's just the count. Hey, a car just passed by. It definitely allows you to guarantee that privacy and that the data that could be personal stays on the edge, or actually not even stays on the edge, because you just keep that frame that you want to keep if it's relevant, and you can actually add your filters on top.
That's a great point, Olivier. Actually, that's exactly what happens. Basically, the frame is here on the edge device, and the data is actually going to the cloud, where you see this in time series insights, right? Like here, what you're seeing is basically the number of cars seen over a 36-hour window, and you're seeing two series here because one is for the left crossing, one is for the right crossing on the freeway. And you can do something like this, or you could go and say, you know what, I want to understand how my traffic grows over time. And this is a cumulative count across those two lines of interest over a 36-hour period. Or you could say, I'm just going to show everything in the same graph. I can see individual counts, or I can understand how my traffic grows. Now, this is a simple use case, but it's still powerful because it gives you a way to understand specifically, let's say on 520, where the camera was pointing outside my office, how traffic grows, when is the rush hour, or when people are moving at a lot on the freeway. So these are the kind of analytics you can run with simple cameras by integrating with this common pipeline, while being accurate, while being really efficient on the edge.
That's great. And actually, once you have the data up there, then you can send that to Power BI, any other type of application for your business operators to get the insight they need for their own work.
Exactly.
So that's a great demo, Avi. So you talked a second ago about efficiency, and I want to go back to Ganesh for a minute so that we can discuss real quick the efficiency of Microsoft Rocket. So what is the gain in terms of performance that we should expect? So let's go back to the presentation. Let's give it to Ganesh to tell us a bit about these performance enhancements and why people should care about going to Microsoft Rocket project.
Sure, Olivier. So we've benchmarked the two containers that the LVA and the Rocket containers that Avi just demonstrated working in tandem on a whole bunch of real-world videos. One was the freeway pointed at one was the freeway video that was essentially counting cars driving on either side, either direction of the freeway. The other one was placed in front of a parking lot to understand parking lot occupancies. And the third was pointing to a driveway in a restaurant so that they could be alerted on whenever a new car or a person is walking in. So we did a benchmark on a whole range of GPUs, from more wimpier ones that are closer to what the edge would be to the more powerful ones as well for the whole spread. And as you can see on the graph there on the right, for the three video streams that I just talked about, we are measuring the processing frames per second of these LVA and Rocket containers working in tandem. The baseline that we're using is running this YOLO V3 neural network model on every single frame. So that's the blue bar. And clearly we can see that for the two cascaded options, the full cascade and the heavy cascade, the improvement in the processing speed is substantial. Overall, if you look at it, there is like a 9 to a 17 times higher processing speed compared to running YOLO on all the frames. This essentially speaking to the fact that by filtering out frames where you don't have to do much of the work, or as Olivier said, being lazy when we can, this leads to a lot of efficiency. And this higher processing speed essentially translates to more video streams that can be processed in one edge box, thus addressing this problem about the total cost of ownership. We can process many more streams on the same edge box, hence you can provision less on the edge box and so forth. One more thing I want to point out, especially for the freeway videos, is the bar marked BGS, which stands for background subtraction. What this does is, as part of the pipeline, it doesn't even call the DNN to confirm if the object that crossed a line of interest is a car or not. And this is very video specific, scenario specific. Like for instance, on the freeway, you could make a reasonable assumption that the only moving objects are going to be cars. So this leads to a substantial efficiency improvement as well. And as Avi had pointed out in his demo, all options for the different kinds of cascaded pipelines that you can use are just simple command line parameters that you can just pick and deploy.
Like this is really putting a big stress on the I in AI vision, right? The intelligent part, and really optimizing your pipelines. So what's next? So now, right now, people and developers can find the samples that you have, and we have these cascaded pipeline samples with the notebooks. Do we have the containers as well on the Azure marketplace? And what's next for Project Rocket here?
Yes, we do have the containers in the Azure marketplace. There will be links provided to it along with the notebook experience that Avi talked about. But taking a step beyond just the cascaded pipelines, there are a whole suite of technologies that we've developed for improving efficiency of video analytics towards our stated goal of democratizing video analytics. One is the pipeline optimizer itself. There are a whole bunch of factors that affect the accuracy and the cost of the video processing depending on the scenario. And so as part of it, how do you pick the best pipeline? How do you pick the best resolution factor, the frame sampling factor? So we would be, one of the things we would be hopefully releasing soon is a video pipeline optimizer that allows you to automatically pick the best set of configurations by balancing between the cost and the accuracy. Moving beyond that, we also want to extend the pipeline from running just on the edge to also call upon the cloud sparingly whenever required. In this pipeline, if you recall, we talked about getting a result from a more heavier neural network if we needed more confidence. That neural network, as you can imagine, could be in the cloud too. The cloud has a lot of resources. So if we do need, we could go to the cloud, perhaps get an additional confidence as well. So that edge cloud execution is another thing we hope to extend. And finally, we are very cognizant of the fact that privacy of the videos is an important thing. So another technology that we are working on is towards adding access control and obfuscation in the video, such that only objects of interests are eventually presented to the application, not the entire frame, if not required.
This is super complete. I love that. I think you guys are touching on everything. In the edge/cloud execution, are you guys also considering the fact that you could eventually have a way of doing continuous training of the models as well? So is it something that's part of that story as well?
Yes, absolutely. Yeah, that is something we are working on as well, because the edge does provide a thing where we deploy a compressed model, but then the video changes over time. The models have to be updated. So we're very much working on continuously updating these light models as well. And hopefully we'll have more to share on that soon.
Well, you know where to find me when you have this more to share. I'll be happy to have you guys again on the IoT show. If you guys want to learn more about Microsoft Rocket and live video analytics integration, you can go to aka.ms/IoT show/rocket. As simple as that. So Ganesh, Avi, thanks a lot for joining us on the IoT show today. I hope to see you soon. And for everyone who was watching this, don't forget to subscribe. See you soon. Bye.